Now, I assume you guys recognize your old favorite formula here, area of a triangle. Now, the problem is with this thing, area of a triangle only works if you have the base and the height, and the base and the height are always identified as a right angle to each other. What happens if you got a nice little triangle that doesn't have that information? Okay, so first one here that we've got, these are formulas here for finding the area of a triangle that is in the form of side angle sides. So we know a side, we know an angle, and we know a side. Then these formulas will be used to calculate the area. Now, the thing is, I've actually used this stuff in the past. You always sit there and you wonder, well, where is there an application for this? Back when I was in Lee Center, this was probably about 20 some odd years ago, I had gotten a call from one of the local farmers. It disagreed with ASC about the size of one of his fields. It was a small triangular piece. But when Co-op would come out and spray for him, he got one measurement. When he would go and figure out what he needed for planting, he got approximately the same measurement as Co-op. But ASC always said that it was something way different. And so he wanted to know which one was right. So he gave me the dimensions on the field, and I had found it on, how they got the GIS photos now. They had stuff like that back in the day, and also Google Earth was just starting to come up with some of these extra nice, wonderful pictures. So I pulled up a picture. So I got to look at it, and I was able to go and set the dimensions up on it. I figured it out, and yes, ASC was wrong. They were off by, I think, about 2 acres. Just the way they were doing it. I think they were always coming up too short. He was always coming up that he was, getting more. And the answer that I came up with was close to what he was figuring out for planting and close to what Co-op was figuring out for when they had to spray it. So it does have application. Mind you, that's once that I've ever used it to do something like that. But those are the formulas that you've got. Okay. Now, they do put this in here kind of like, the area of triangle K equals 1/2 the product of two sides times the sine of their included angle. And that's kind of an easier way of remembering the darn thing. So if you've got two sides and you know the angle included, you can go and figure this out. Now, Heron's formula. There's a feller by the name of Heron of Alexandria, and if I'm not mistaken, it has shown, one of you guys wrote about him. I can't remember exactly which one of you guys did, but he came up with all kinds of nice little things here. And he's got a formula for the area of a triangle with sides A, B, and C. So if you know what the sides are on your triangle, you can drop it in here, and you're able to go through and figure it out. So it's really just, taking the formulas and applying the darn things, and away you go. Nothing is really all that spectacular on here. Okay? So, because these are just simply application problems, it's just plug and grind, I'm going to end it right there. Just make sure that you've got them written down and identify the sides. And as always, draw it out.